All right, let's jump right in. Today, we're going to pull back the curtain on a language that's absolutely key to navigating the giant, tangled web of data that quietly powers so much of our digital lives. We're going to demystify SPARQL.
So think about it for a second. Most of the world's information doesn't live in a nice, clean spreadsheet, right? It's more like a huge graph, a network of connections and relationships. So how do you ask questions of that? How do you say, show me all the movies directed by this person, and also show me the composers for those movies? That is the exact problem SPARQL was designed to solve.
So here's our game plan. First, we'll cover what SPARQL actually is. Then, we'll dissect a query to see how it's built. We'll run through a fun little example with some cats, because why not? After that, we'll look at what else SPARQL can do beyond the basics, and finally, we'll see where it all fits into real-world applications. Sound good? Let's do it.
Okay, so what is SPARQL? Well, probably the easiest way to wrap your head around it is to think of it as the SQL for graph data. If you've ever used SQL to pull data from a traditional database, you're already halfway there. It's the same idea, just for a different shape of data.
Now, the official name is SPARQL Protocol, an RDF query language. And yes, the S in SPARQL stands for SPARQL. It's one of those fun little recursive acronyms you see in tech. It's a formal standard from the W3C, that's the World Wide Web Consortium, and its whole job is to retrieve and even manipulate data that's stored in something called RDF, which is just a way to model data as a graph.
And you know, this isn't some brand new, untested thing. SPARQL 1.0 actually came out way back in 2008. But then in 2013, SPARQL 1.1 dropped, and that was a huge deal. It added the ability to change data, not just read it, and to run queries across multiple databases at once. That made it incredibly powerful.
All right, let's pop the hood and see what one of these queries actually looks like. I know, the syntax might seem a little intimidating at first glance, but I promise, once you see the basic building blocks, it all starts to make a lot of sense.
So pretty much every query has 5 main parts. You've got prefixes up top. Think of these as just nicknames or shortcuts for really long web addresses. Then there's the result clause, like select, which is you saying, here's the stuff I want you to give me back. The dataset definition tells it where to go looking. The query pattern inside the where clause, that's the real heart of it. That's your actual question. And finally, you've got modifiers to sort, filter, or limit your results.
And this is what that structure looks like. You can see it clearly here. You declare your prefix shortcuts, you select your variables, you say from which dataset, you define your pattern in the where clause, and then you can clean it all up with order by. This is the fundamental pattern you'll see over and over again.
Okay, enough theory. The absolute best way to learn a language is to actually use it. So let's get our hands dirty with a really simple, concrete example. We are going to query a tiny dataset about cats.
First up, let's meet our data. This is Victor. In our little data graph, Victor's an entity, he's of the type cat, and he has a name Victor. Pretty straightforward, right?
And Victor's not alone. Here are his friends Gaston and Bettina. They're set up the exact same way in our data. They're both of the type cat, and they each have a name. So now our tiny data universe has 3 cats in it.
Okay, let's write the query to find our feline friends. We start with select. We're asking for 2 pieces of information, and we create variables for them using a question mark. So question mark cat and question mark name. Now the where clause is where the magic happens. We're telling the system, I want you to find anything. Let's just call it cat for now. That is a type of XF cat. And for every single match you find, I also want you to grab its FOAF name and stick that value into my question mark name variable. And voila, here are the results. The system scanned the data, it found our 3 cats that matched the pattern we described, and it returned their unique identifiers and their names, all in a nice, neat table. It did exactly what we asked it to. See? Not so scary.
But just grabbing tables of data, that's really just scratching the surface. SPARQL has this whole toolkit of other query types that let you interact with your data in some really cool and sophisticated ways. So besides select, you've got 3 other big ones. Construct is super powerful. It lets you build a whole new data graph from your results. Ask is the simplest of all. It just gives you back a yes or a no. And describe is kind of like asking the server, hey, tell me what you think is important about this thing.
The difference here is really about the kind of question you're asking. A select query is like saying, show me the names of all the cats. You expect a list back. But an ask query is more like, hey, just tell me, are there any cats in this data at all? And for that, all you need is a simple true or false.
Now, check out a construct query. This is where things get really interesting, because we're not just finding data anymore, we're actually transforming it. This query says, find everything that is either a cat or a person, and then build me a brand new graph where all of them are now classified as an agent. This is a huge tool for integrating data, letting you merge different kinds of information into one standard format.
Okay, this is all great. We know how to write a query. But so what? Where does this actually fit inside a real working application? How do you get from writing a query to having a piece of software that people can use?
Well, in a typical web application, SPARQL acts as the bridge between your app's brain and its data. At the very back, you'll have a special kind of database called a triple store, something like Stardog or Fuseca, which holds all the graph data. Then, your application's logic layer, maybe written with a framework like Apache Gina, is what actually builds and sends the SPARQL queries over to that store. The results come back to the logic layer, which then passes them up to the front end to be displayed to the user.
And the great news is, you don't have to build this all from scratch. There's a whole rich ecosystem of tools out there. Apache Gina and RDF4J are absolute giants in the Java world. Stardog is a really powerful enterprise-grade platform. And big cloud providers are in the game too, with services like Amazon Neptune. These are the tools that power real-world SPARQL applications every day.
So, we've covered the what, the how, and the where. SPARQL is basically the key that unlocks these massive public stores of interconnected knowledge, like DBpedia, which is essentially the structured data from Wikipedia. So that brings us to the final, most important question. Now that you know the language, what questions would you ask the world's open data?